Welcome to JSM Learn. Now we are going to solve previous year IIT JEE Main questions from the topic sequence and series, and the subtopic is geometric progression and miscellaneous sequence. Let's see the first question. Here alpha is given equals to 1 by 4 plus 1 by 8 plus 1 by 16 plus up to so on so infinite many terms, and beta is given equals to 1 by 3 plus 1 by 9 plus 1 by 27 up to so on so infinite many terms. Then we are going to find the value of 0.2 whole power log alpha with the base root 5 plus 0.04 whole to the power log beta with the base 5 we are going to find now. Here alpha is equals to 1 by 4 plus 1 by 8 plus 1 by 16 and so on. By observing these terms, we got to know that 1 by 2 is the common ratio for this GP, and the first term is 1 by 4. In the second sequence, it is given that 1 by 3 and 1 by 9. Then next 1 by 9 and 1 by 27. Here common ratio is 1 by 3 and the first term is also 1 by 3. We know that sum of terms of infinite GP is equals to A by 1 minus R. So by using this formula, now we are going to find the alpha value and beta value. Alpha is equals to sum of infinite many terms for this GP. By using the formula A by 1 minus R. Here it is A1 by 1 minus R1. By substituting A1 is equals to 1 by 4 and R1 value is 1 by 2. We'll get 1 minus 1 by 2 is equals to 1 by 2, right? So on cancelling these two, we'll get 1 by 2 as our alpha value. Now we'll calculate beta value by using the same formula, sum of infinite terms of GP, that is equals to B1 by 1 minus R2. Here B1 is equals to 1 by 3 divided by 1 minus 1 by 3, that is equals to 1 by 3 divided by 2 by 3. Here we'll get beta value is equals to 1 by 2. Now we are going to solve for this given condition. We found it out, alpha value is equals to 1 by 2 and beta value is equals to 1 by 2. Now we are going to substitute these values in the given expression. I am rewriting this given expression as we know a property of logarithm, that is equals to a to the power log x base b. We can interchange these two variables. We can write this as x to the power log a and to the base b. By using the same property over here, I am interchanging these two values. Alpha power log 0.2 whole with the base root 5 and beta power log 0.04 with the base 5. Here 0.2 can be written as 5 power minus 1 and this can be written as 5 power 1 by 2 plus beta power log of 5 power minus 2 with the base 5. 0.404 can be written as 5 power minus 2, that is nothing but 1 by 25, which is equals to 0.04. Now by using the property of logarithm, that is a power m with the base b power n, this can be written as m by n times log a to the base b. By using this property, I am simplifying these two logarithms. Alpha power minus 1 by 1 by 2 with the log 5 to the base 5, and beta power minus 2 into log 5 with the base 5. Log 5 base 5 value is 1, right? We know log a with the base a is equals to 1, right? For any value of a, it will be 1 only. So here this goes 1 and this will also goes 1. It will be minus 1 by 1 by 2, right? So this will become alpha power minus 2 plus beta power minus 2. So this can be written as 1 by alpha square plus 1 by beta square. We find it out, alpha is equals to 1 by 2 and beta is equals to 1 by 2. By substituting 1 by 2 over here, we'll get 1 by 1 by 2 whole square plus 1 by 1 by 2 whole square. On solving this, we'll get 4 plus 4, which is equals to 8 as our final answer. Let's see the next question. Here a quadratic equation is given and alpha is the minimum value of product of its roots. Beta is the maximum value of sum of roots. We are going to find the sum of first 6 terms of GP, whose first term is alpha and the common ratio is alpha by beta. By comparing this quadratic equation with the general equation, we know that sum of roots is equals to minus b by a, product of roots is equals to c by a. Here alpha is given that minimum value of product of roots. First we will see product of roots. Product of roots means c by a. Here we got n square minus 2n plus 2 whole square by n square minus 2n plus 2, which means by cancelling these two, we got product of roots is equals to n square minus 2n plus 2. For this, we are going to find the minimum value, that is equals to alpha. So next, beta is the maximum value of sum of roots, which is equals to c minus b by a. Here b value is minus 3, which is equals to minus into minus 3, that will become plus 3, divided by a value is n square minus 2n plus 2. So we got sum of roots is equals to 3 by n square minus 2n plus 2. For this we are going to find the maximum value, that is equals to the beta. So beta is equals to maximum of 3 by n square minus 2n plus 2. So in this function we are going to find a maximum value of constant by some varying function. So for this we can write this maximum value attains at minimum value of the denominator function. So here also we are finding the same, right? So now we'll proceed for this one. Minimum value of n square minus 2n plus 1 and plus 1 I am writing. So on simplifying this, we can write this as minimum of n minus 1 whole square plus 1. So here we are having a perfect square plus constant. So here n belongs to all reals, right? So perfect square value can be greater than or equals to 0. So here minimum value is 0, right? By substituting n is equals to 1. So we got minimum value of this function is equals to 0 plus 1, that is nothing but 1. So for beta also we are going to find the minimum value of this same n square minus 2n plus 2 function, that is equals to minimum value is 1, right? So by substituting the minimum value over here, we get 3 by 1 as the beta value, that is equals to 3. So we got beta is equals to 3 and alpha is equals to 1. We are going to write here first term is given that equals to alpha, that is equals to 1, and common ratio for this GP is alpha by beta, that is equals to 1 by 3. Now we are going to find sum of n terms of a GP. We know that sum of n terms of GP is equals to a into 1 minus r power n by 1 minus r. Here n is equals to number of terms in GP. We know that a is equals to first term and r is equals to common ratio. So we are going to find the first 6 terms sum of the GP. So by substituting n is equals to 6, we are getting 1 minus 1 by 3 whole to the power 6 by 1 minus 1 by 3. So on simplifying this, we will get 3 power 6 minus 1 by 3 power 6 divided by 2 by 3. On cancelling this 3 with 3 power 6, we will get 3 power 5. That is equals to 3 power 6 minus 1 divided by 2 into 3 power 5. So 3 power 6 value is 729 minus 1 by 2 into 243. So on simplifying this, 728 by 2 into 243 will get 364 by 243. So this is the sum of 6 terms of GP. In this question, it is given that sum of n terms is equals to 6n cube, which means a1 plus a2 plus a3 plus up to so on so an, that is equals to 6n cube. I am denoting it with Sn, which is equals to sum of n terms. Now we are going to write nth term of this sequence, which is equals to sum of n terms minus sum of n minus 1 terms. Now we are going to find the sum of n minus 1 terms by using this formula. Instead of n, we are substituting n minus 1 in the place of n. So we got sum of n minus 1 terms is equals to 6 times n minus 1 whole cube. Now we are going to find nth term of this sequence, which is equals to Sn minus Sn minus 1, which is equals to 6n cube minus 6 times n minus 1 whole cube. That is equals to 6 times n cube minus of n minus 1 whole cube, right? We will get 6 times 3n square minus 3n plus 1. So this is our nth term. Now I am rewriting this nth term as 6 times 3n of n minus 1 plus 1. So now we are going to find the n plus 1th term also. Now we got nth term, right? So now we are going to find this n plus 1th term. So a n plus 1. So here we are going to substitute n plus 1 in the place of n to find out the n plus 1th term. So 3 times n plus 1 minus 1 plus 1. So on simplifying this, what we will get? 6 times 3 into n plus 1 into n plus 1. So we will get 6 times 3n square plus 3n plus 1 we got, which is equals to a n plus 1. So on finding these two terms, which is n plus 1th and nth term, we are going to substitute in this given condition. Now we are going to find the value of this given expression. We got that a n plus 1th term is equals to 6 times 3 k square plus 3k plus 1 and ak, which is equals to kth term, 6 times 3k square minus 3k plus 1. So we are going to subtract these two terms, right, which is equals to a k plus 1 minus a kth term, which is equals to what we will get? 6 times 3k square plus 3k plus 1 minus 3k square plus 3k minus 1. So here 1 and 3k square will get cancelled and the remaining is 6 times 6k, that is equals to 36k we got. So we are going to find the sigma value where k is running from 1 to 6, ak minus ak plus 1 minus ak, right? That is equals to 36k we got divided by 36 whole square. So on cancelling this 36 and 36, we got that sigma k square. We are going to find from k is equals to 1 to 6, which is equals to 1 square plus 2 square plus 3 square up to so on so 6 square. We know the formula sigma n square is equals to, which means 1 square plus 2 square plus 3 square up to so on so n square, which is equals to n into n plus 1 into 2n plus 1 by 6. So on substituting 6 in this formula, we will get 6 into 7 into 13 by 6. So on cancelling this, we will get our value is equals to 13 into 7 times, right, which is equals to 65 plus 26, that is equals to 91. So on solving this expression, we got 91 as our answer.